6. So that's where you need your calculator today. Make sure your mode is in degrees. Very, very important. Easy to mess that up.
20.63.
Okay. Now to find B, you can either use sine, cosine, or tangent, or you can just use Pythagorean theorem. It doesn't matter which one. Which one which one suits you?
Probably Sokotoa.
Okay. So, you can use cosine again if you use this angle. Or if you want to use this angle up here, 46, you have to use sine. If you're trying to get to the opposite.
Mhm.
All right. So do you want me to set it up, or do you feel like you got
It'd
it?
be sine 46 equals b over 29.7, which is
Yep.
29.7 times sine 46.
Yeah.
So then 21.36.
All right. Very good. And we probably should have units.
Oh, yeah.
Okay. Any questions on that?
No, I just needed that clarification, but I'm all good on that.
All right. Let's just not just maybe not do the next one, but we'll just set it up. Do 30 here. P, B, A. This is little c, little a, little b. So this is 51.7 degrees. Little a is 28.1. And if it were me as a student, well, as a teacher, I would definitely have a table off to the side so that students could just fill in their answers. So that's all I want to grade. But you can see most of it is given. Like C is 90, 51.7. And then A, you can figure out A pretty quickly because they add up to 90.
A would be,
That's to add up to 90 with this one here. What's the angle A?
oh, sorry. I just realized that I was on mute and I didn't mean to be. It'd be 38.3.
I do that all the time. Well, not all the time, but I do that enough that I'm just like, oh boy, I wish I knew. So that, Zoom, they just don't like, it's a great product and there's other ones, but it's like that's a known issue. Like people,
Yeah.
like it should like almost like flash up like hey, the other person's talking, their microphone's going, and they're muted or something like it.
Mm-hmm.
Can't do it. So okay, now that's why I said like you're not. It's not like you're finding it. It's like you're finding everything, but you're not really finding everything. You got to find two sides. So
Yeah.
like it doesn't matter which angle you use, but you are going to use this side. So if you use 38.3, if you're going to use sine, you're going to find C. But you could also use tangent. A lot of students default to tangent. They'll say tangent of 38.3 equals 28.1 over B. Okay, and maybe you're okay solving this, but notice if you do tangent 51.7, it's B over 28.1. The variable's in a better position potentially.
Yeah.
So I would use the one on the right is I guess the point. It's like and it's
Mm-hmm.
but I have the benefit of,
Simpler.
I do this all the time and so it's not mandatory. It's just, are you comfortable solving, where the variables are on the bottom?
35.58.
Yes, that sounds right. So once you get B, you said 35 point, what did you say?
35.58.
Okay. So now to get C, you can use Pythagorean theorem, or you can use sine, cosine, or tangent, or SOHCAHTOA, like you're saying.
Um,
So it's up to you. Like it doesn't matter to me, but you can use either one now. To find C, you're going to use sine or cosine, to find it.
sine sine 38.3 equals 28.1 over. Oh wait, no,
Over
because
C.
we want
Yeah, over
the
C. That's
on the
okay.
bottom.
That's okay. It just means that it just doesn't work out as nice. Um,
It would
do you know how
be
to solve this?
28.1 over sine
Yes,
38.3.
exactly.
45.34.
And so you could then check it with the Pythagorean theorem. Like if you're really like, I wonder if it's right.
Um, so do you want me to check it with Pythagorean?
No, I'm just saying like you have an extra tool to be able to do that.
Okay.
All right. So actually, I didn't mean for us to solve that one, but we did. That's probably a good thing. We have plenty of time here. So the next problem is the 34, where you are given sides. You're given sides instead of angles. That's C, V, A. It doesn't really matter, but A is 958. B is 489. So you typically do want to use Pythagorean theorem in this case to find C. Don't forget about that one in your toolbox. So
Okay.
could you calculate that for us, please?
$1,075.59.
So maybe 1076. You'll have to check with your instructor on rounding.
Okay.
Don't forget units though. That's probably the more important thing. You might even put that at the top of the exam, units with some exclamation points, things to check, to make sure that you've done. Now we haven't done this yet, but to find an angle, you use a ratio of sides. So let's say we wanted to find angle A. The tangent of A is the opposite over the adjacent. It's 958 over 489. But we have to get to A. Like we have to undo tangent. And I assume you guys talked about this in class. To undo tangent, use tan inverse on both sides.
Mm-hmm.
Okay, so A is the tan inverse of 958 over 489. I don't think you'll have any confusion about how to do this, but a lot of students do. They like, well, when do I use tangent? When do I use tan inverse? You're solving for A. So when you have to undo tangent, that's when you use the inverse. Because you had all three sides, you could have actually used sine, cosine, or tangent. Go ahead and calculate this for us, please.
62.96.
Okay, so maybe 63 degrees. So notice once you get that angle, you can immediately find this other one.
Mm-hmm.
So you just find the one that adds up to 290.
Okay.
So the typically you do find the third side, then you use a trig function to find the one of the angles using the inverse, and then you find the so let me grab, let's have you try 36, do 36 next. All right. Again, drawing the triangle, definitely a good idea. Little c is across from it. That's 647. That's the hypotenuse. Your choice where you put A and B. B equals 219. Little a is there. So I would first find little a using the Pythagorean theorem.
$608.8.
Okay. So maybe 60 609 units. Always forget your units there. Okay. Now to find the angle A, let's just say we wanted to find A. We really want to use the given sides, that one and that one. Which trig function should we use? Which trig function uses the one right next to it and the one over here, the longest one?
Um, Cosine.
Cosine. So you can say cosine of A equals 219 over 647. And then how do you undo cosine? Well, just like before, you take the cosine inverse of both sides. Once you get that angle, you subtract it from 90 to get the other angle.
70.2, so 70 degrees.
70, check with your instructor on rounding. So that's 20 degrees like that. Good. Okay. So the next grouping of problems are these word problems. We should talk briefly about the angle of elevation and the angle of depression. So when you're looking up, this is the angle of elevation. And then when you are looking down, like let's say you're in an airplane looking down. I'm not really good at airplanes, so I'll just say airplane. This is the angle of depression. Okay. And the reason you might need to know all this is because if you combine them in a picture, like let's say there's something looking, this is your picture. Sorry, so let's say this is the angle of depression up here. This other angle is the angle of elevation, and they are exactly the same. So these are actually the same. And you'll see that in some problems potentially. And I guess it's not made clear in the classroom, but they're the same. Like if you're
Mhm.
here and you're looking up, that's the angle of elevation. Doesn't have to be to the right, it could be to the left. The angle of depression is from the horizontal looking down. They are the same by alternate interior angles. Any thoughts on that?
Okay. That's
And there's two types of problems. There's those where you get the picture, and there's those where you don't get the picture. It looked
mhm.
like in these three, they give you the picture. I don't know if that would be the case. They also have a lot of words that are not really all that important. It's kind of like the SAT stuff we've talked about. You want to go right to the last sentence and be like, what is it that I actually care about? I need to find the cloud ceiling, which is basically how high the clouds are from the ground. So like there's a lot of words to then basically tell you you're finding the height of this, but you can read them if you would like. But they're typically asking you to solve for a side or an angle in the triangle. So don't overthink it. It's either a side or an angle.
Okay.
So I mean, you can read all this if you want. It's not, I mean, I don't know if you find this interesting, but you're finding the height of this triangle. And then because the observer is 6 feet off the ground, the cloud ceiling is the height of the triangle plus the 6 feet from the observer. But what we care about is finding the height of the triangle. We're given this right here. We are to assume that it is a right triangle. You are to assume right triangle until further notice, which will be about, one more class period. And the next week you'll do non-right triangles. So how do you find the height? Well, you've got an angle here. You're trying to find the opposite, and this is the adjacent.
Okay.
So which trig function to use with opposite and adjacent?
Um, cosine.
Cosine is adjacent over hypotenuse.
Oh, sorry. Uh, tan.
Yes. So the tangent of 30 equals h over 1000. So could you solve that for height for us, please?
577.
Okay. Now that is not the final answer. That is just the height from the searchlight. And we know that the observer and the searchlight are based the same height. So the cloud ceiling is 577 plus 6 or 583 feet.
Okay. Oh yeah. Could we
So,
do 59 and 61 for
yeah,
these?
yeah, we can do them all. Yep. All right. So again, probably like there's a lot of words here. I, I don't even know if I give the appearance. I don't read any. I just go right to the thing that they're asking for. You could read it if you want. Maybe it's I think more interesting to go and see the pyramids. Um,
Yeah.
that
This one
really.
really threw me off.
But like when you just draw this right here, you're like, okay, there's a triangle, there's a height, and we need to find that angle. Well, we've got a problem. The problem is we don't have this length right here. Would you agree?
Hmm.
Yeah. So we got a problem. So we need to find the diagonal, and there's another triangle here, 700, 700. And if we could find the hypotenuse, we reasonably can assume that this is right in the center of the pyramid, the top. I mean, I don't know if you've been to a pyramid. I have not, but I think it's reasonable at the center. So if we could figure out the hypotenuse of this triangle, let me maybe color code it here. This one right here is the same as this one here. If we could find the hypotenuse, we could then cut it in half to figure out where the, straight up is in the pyramid. So how do we find the hypotenuse of this triangle over here?
Um, Pythagorean.
Yes. Could you do that for us, please?
900, 990.
Okay. So if we cut that in half, that is the length. And I'll put this in blue here. So half of that is this over here. So that's the 990.
Okay.
And that is enough to allow us to find the angle. Now, relative to this angle, what is 200? What is 990? And your choices are adjacent, opposite, or hypotenuse.
Um, Tan.
And because it's opposite and adjacent, tangent of theta is 200 over 990. You can solve for theta. Theta is tan inverse of
11.
290, 11 degrees. Okay, seems reasonable. Yeah, I agree. That
Okay, that
actually,
makes
that's actually,
sense. Yeah.
it's yeah. I mean, they're at a lot of words, and you needed to recognize.
It
I mean, it
makes a
doesn't even
lot more
show.
sense when it's like explained like that. Yeah.
Yeah, I mean, you got to know that that's a right triangle. Which, I mean, I don't know. Maybe I don't know how you would know that. Like, but whatever. That is part of it. Like that's where you go and ask your instructor. You say like, "Hey, is this a right triangle?" And they look at you like, "Well, you should know that." And you're like, "All right, I'm gonna assume it's a right triangle." And then you look and see what they say, and they're like, "You, you can read. You can really get a lot of information, even if they don't answer." So, all right. Next one here, the height of Mount Everest. A lot of people, it's gonna sound horrible, die every year trying to reach Mount Everest. There's some great documentaries on that if you're into that kind of thing. Um, so they're they're trying to show you that there's another triangle here, and whatever the height is, you're going to add the height to this one right here. Because the total height of Mount Everest is I'll call it a big H, and big H equals little h plus 14,545. Is that clear? Like if we found now they throw you off here by putting this in miles. So you do have to convert this to feet. And I don't even know if they tell you, but I guess you're supposed to know that there are in 1 mile, there are 5,280 feet. Is that something you know?
Not off the top of my head, but I'm assuming she wouldn't give us conversions like that without telling us.
That's where you go ask. You say, look, I don't know this conversion. Is this the right conversion? And say, and you can even do this. This is actually a really good thing to do. I think is you could say like, well, my opinion, of course, is like if you don't know the number and you're not sure, you say, I'm going to use this as my, like you write a note, you say, I'm using this as my conversion factor. And if my answer is right using the conversion factor, you want to go back and basically have some justification for like why you got your answer. Like, I don't know it, but I'm assuming this one is. But I would just ask, make sure you if you can. So we need to convert that to feet. Now, once we get that value, we're going to have the hypotenuse in feet, the height, and they give you the angle. They give you the angle there. So you're going to have enough. You need a side and an angle, basically. So could you get a hypotenuse here?
Um, 142,630.
Okay. So now to find H, we've got this angle, opposite hypotenuse, sine of 5.82 equals H over 142,630. You can solve for H now by multiplying both sides by 142,630.
Oh wait, it's that 0.752. So would I round it up to 142,631?
Yes, you can. I mean, we're talking about that number is so big that number isn't super significant, but sure, like that's a good thing to do.
Okay. 14,463.
Really? Okay. I guess it is really tall. Huh. Do you know how tall Mount Everest is?
No idea. I can look
I
it
have no
up.
idea. Yeah, I'm gonna look here because it doesn't seem right. But what do I know? Oh, that is right. Okay, you said 14,000. Sorry, one more time. You're right. Your answer right. Well, just give me that number one more time. You may be muted.
Hello?
Yes, you're there now. Hello, hello. What is the height again? 14,000.
463.
Okay, so the height is 14,463 plus 14,545. I did a quick search. We're in the right order of magnitude for this. I didn't realize how much taller it was. So in Colorado, there's a big deal about climbing 14s. Um,
Oh,
yeah, it's a big deal. You get the sticker on the side of your car to do it. Um, the thing is, you're starting a lot higher, so I don't know. Like, it ought to be like how much, did you? You're already at a mile high there, and then you drive up. I mean, it's not like you're climbing up 14,000 feet. You're climbing up like 4,000 feet. People
mhm.
drive up, it's parked, and then really interesting in Colorado. There's a lot of lightning strike on these peaks. They're actually very dangerous to be
Really?
hiking. Yeah. There's only certain
Oh,
parts of the year you can do it, not because of snow, but just lightning. You're like, really? Yeah.
that's
All right.
surprising.
Yeah. Lots of useless information here. All right. So the next question says, does the curvature of the Earth, so they're saying like they actually used the wrong number. They're like, oh, it was actually 100 miles away, not 27. Um, and the idea is like, well, does the curvature of the Earth make it seem taller or shorter? So if we draw a curve, there's the mountain, and there's where you are. That's like a cat. Um, does it look taller, or I don't know. I don't actually know.
Taller?
I guess it looks taller, yeah, than it actually is.
The answer key says shorter though.
So go with short. I don't, I don't know. I guess the idea is if it's on a flat surface, that's what it is. But it's like some of it's cut off by the curvature. So like it's I don't know. It's like it's not as tall. Like you think it's up here, but it's really over there, so it looks taller. So it's actually shorter, or it is taller, but it looks shorter.
Okay.
You're probably not going to get this on your test. Like this is
Yeah.
not a fair question to ask. Um,
Okay.
okay. Other stuff you want to work on? Do you want to try some of those other problems? Um,
We
I'm
do some
sorry, go ahead.
uh we could do like a problem from last week, like the questions I sent.
You mean on Tuesday or the week before?
Oh, Tuesday, sorry.
Yeah, let me look for those. All right, let's look at like 40. Is that okay?
Mhm.
These are way more difficult than you're going to get on your, well, you said that your tests are more difficult. All right. Length of a side of a piece of land. So the thing that you got to really like notice here is there's a right triangle on the bottom and there's a right triangle up here. And then like this is 30 degree, 50 minutes there. So you have enough to find another part of the triangle, right? You can either find like up here or you can find that's down here. And we'll just call it like B and C, for example, right? Do you agree that you could find either B or C in this problem?
Mhm.
So
We could
now,
do.
like before we decide which one, let's think about what we're trying to get to. We're trying to get to X, which means that we really need this right here because this is also C, right? So we really want C.
Yeah.
Like you could find B, but B would be useless to find.
Hmm. So then we could do
So how would you find that?
cosine.
Yes. So cosine of, and then it's 30 plus 50 over 60. That's the conversion from the minutes to the decimal equals 198.4 over C. So once we find C, we're going to use it to find X, but we're going to need some more information.
231.
Okay, so that's 231. Now to find X, we either need like this down here or an angle. And we definitely aren't going to get this down here because there's nothing for that. But we can get the angle. See how they give you the whole angle up here and part of the angle there? You can
Hmm.
then subtract to find the full angle. Now, it's a little weird to subtract when it's in the degrees and minutes. So I would probably do the full conversions like 52 plus 20 over 60 minus 30 plus 50 over 60, like that.
Okay. I have a problem that I was wondering if we could do. I'll send you a picture of it.
Yeah, we are running out of time, so we can transition right to that if you would like.
Yeah. Did you get the picture?
I'm checking.
In the chat.
Oh, in the chat. Another great feature of Zoom. The they don't get the notifications don't appear unless you're right on it. All right. Thank you. All right. Okay. Plane flies, a plane flies 1.3 hours at 110 miles per hour, bearing at 38 degrees. So that's referring to this right here, 1.3 times 110. It then turns and flies 1.5 hours at the same speed on bearing 128 degrees. So this length right here is 1.3, I'm sorry, 1.5 times 110. All right. And this angle right here is 52 degrees. And so you can drop an altitude down to get a right triangle there. So you can get that thing here. So what's that? 110 plus 33. This is 143. So you can
Yeah.
find, I'll call it A. And then similarly, 1.5 times 110 ends up being, was that 55, 165. And then you need an angle. So the whole thing at this angle down here after the 128 has to add up to 180. So that's 62 degrees. So you could then use that to find B. and X is A plus B.
Okay, sounds
Is
good.
that clear? We did one
Yeah.
kind of like that where like it wasn't a right triangle, so you got to drop an altitude to get that.
Hmm.
A little deceptive, I guess, because you know, maybe you don't know to do that. I don't know how you know, but
Okay, thank you.
all right. Any other basically out of time here? Any other quick questions? I mean, I'll just, you know, point out that this one uses cosine. 52 is A over 143. Sine 62 is B over 165. Yeah, you can solve those pretty easily. Check your units. Units are really important. I'd put that at the top of your test. Make sure your calculator's in degrees. Another biggie that could cause you a lot of problems. Don't forget about the
Yeah.
Pythagorean theorem. Don't forget to ask about rounding. Make sure your answer makes sense. So you're like, what do you mean by that? How could that? Well, like if you get X and X is like 5,000 and all these other numbers are 231 and 198, that's a problem. You know, that I was kind of unsettled by this, but we looked it up and it was reasonable. Um, you know, you got 11 degrees. Well, that makes sense. 700 versus 200. You're going a lot out before you go up. That's reasonable. Okay. Um,
Hmm.
Sometimes they won't physically make sense, 577, like I don't know, 577, but like relative to 1,000, that's pretty reasonable. If you told me 6,000, like that's not reasonable. So that could also be to play into that. All right.